Hey guys, I hope the whole session is visible. I hope there's no issue with the live stream. So if there's any issues, just let me know. Okay. Is there any issues with the stream? Are you guys able to hear me properly? Are you guys able to see the screen properly? Let me know. Okay, so we'll just wait for another like 2 to 3 minutes until people let people join in, and then we'll just get started. Okay. So meanwhile, if you guys have any questions, you can, drop me a chat here, text in the chat here. Meanwhile, I'll just have my, oops, what did I do? Okay. Great. Okay, meanwhile, I'll have the chat as well on my other screen. So if there's any questions that you guys drop in mid of the session, I can answer that quickly. Okay, no problem with that. So yeah. Okay, cool. So all right, so I think we'll just wait for another and we'll start around 5:03. Okay, so meanwhile, if you guys have any questions that you guys want to ask, or if you guys want to talk about anything, you can put a message over there on the chat. We'll just discuss while we wait for others to join. Do you guys have any questions that you want to ask? Do you guys have something to talk about, something that excites you about blockchain tech? Nothing? All right. Okay, no problem. How long this session will be? 1 hour, 5 to 6, or 5 to 6:10, 6:05, depends on how the session goes. So yeah, we'll try to hit around 6. Okay, we'll keep consistent, like 1 hour or 1 hour, like extra 10 minutes or something like that. Right, let's do one thing. Let's just get started, and meanwhile people will join in, and then if they have any questions they can drop a chat, and then we'll interact with them. All right, so let me open up my drawing screen. So today what we'll be doing is, so this I'll just give you an introduction of what we're doing throughout this whole session, throughout this whole workshop. And today this will be an 8 days long workshop where we'll be building a complete full stack platform, a crowdfunding platform with React and Solidity. So what we'll be doing is, throughout these 8 days we'll look into the basics of blockchain, because getting fundamentals right is really necessary. So although many of you guys are already familiar with this, it will be like a revision to you, a good glance. And we'll also answer some of the myths and facts about the blockchain tech and the hype around it. And then eventually we'll start with Solidity, we'll write contracts, and then we'll have React application, we'll integrate a smart contract with a React application, and then we'll see a fully fledged crowdfunding platform. Okay, so coming to my introduction, so my name is Pawan Kumar. So I'll be handling the whole session for you guys, and I've been as a developer for past 3+ years now. I've been worked with various domains, the full stack domain, and then the blockchain domain as well. So yeah, so that's about me. So now let's get started. And today we'll be looking into the fundamentals of blockchain. So we'll be learning about what exactly is blockchain, how does it work behind the scenes, what are all the components that is involved inside this blockchain, and how they constitute to this creation of blockchain. Basically we'll be looking at the whole basics and what exactly is the blockchain and what is it made of. Okay, so have a pretty good drawing screen here, so we'll be doing this in a visual way. So when we say blockchain, don't mind my handwriting here, so I apologize for that, seriously. So blockchain, so when we say blockchain, the first thing that comes to our mind is the logo, right? The B logo, the Bitcoin logo. So here, so let's keep that aside. Okay, let's keep that logo aside, and thus we'll just dive into what exactly is blockchain. What is blockchain basically? So when we say blockchain, what are we referring to? So when you say blockchain, you guys are actually referring to series of a network of computers. Okay, network of computers that are interconnected. That's what blockchain is. So there might be like hundreds and thousands of computers. All those computers are interconnected, so they are connected with each other. So that's what blockchain is. So this is a computer, this is a computer, this is a computer, and these three have connections. Okay, this is what blockchain is. So what are these computers actually called? We call these computers as node. Okay, we call these computers as node. So what is this node? Okay, what does this node do? So when you put up a transactions, right, when you put up a transactions, that transaction actually comes inside this node. Okay, so this node, which is nothing but a computer, will be running a software, okay, a software that is related to the blockchain. So let's say if you are working with Ethereum, this particular node will be running Ethereum chain, Ethereum software basically. And if you're if you're transacting on Polygon, this particular node will be running Polygon software. So basically Polygon chain inside it. So keeping ignoring all those things, if we go to the bare foundation, it's nothing but a computer running a software. Okay, and that has interconnection network. And these interconnection network, we call this as P2P, meaning peer-to-peer. Okay, so this will have a peer connection with one another. There is no third party involved here who is connecting them. Okay, there is no third party, something like that. They are connected with one another directly. Okay, that's what it makes, peer-to-peer connection. And this node, what does this node consist of? Is it just the software running it? It's like a request come in and it will serve the request. It's not something like that. So this node will actually contain blocks. So let's just write a diagram here. So let's imagine, So let's imagine this is a node. Okay, this is a node. And now what's going to happen inside this node? So this node will have a lot of things inside it. Okay, we'll demystify one by one. So first thing is, we'll look into it. What is the main thing? What is the core thing that this node consists of? This node actually consists of blocks. Okay, this node will consist of blocks. Okay, this node will consist of blocks. And these blocks would actually constitute to the creation of blockchain. So blockchain is something about all these blocks together is known as blockchain. So chain of blocks. So this node will have some blocks inside it. But what does this blocks actually mean? What does this block have? So now let's look into it. Let's take a look at what exactly is this block. So when you say block, so what does this block have? So does it have your information? Does it have all the data that you're transferring? Partially, yes, but actually no. Block doesn't contain your data. Okay, let's say I'm actually interacting with a smart contract. Let's say I'm actually minting an NFT, right? I'm minting an NFT, and let's say we have a Bored Ape NFT here, and along with that I have certain metadata. Let's say the title, the description, the token ID, and then some more details like the whether that has a hat or a cooling glass, or is it smiling or is it angry, all those properties. Do you really think all these property would be inside this block here? Okay, this is a block, right? Yeah, let's say this is a block. Okay, do you think all these information would be inside a block? Of course not. The block won't be storing all this information. Okay, so whatever the information that you are storing on the blockchain, that will be stored in a hard in the disk or a hard drive of EVM. So these nodes, okay, this node will be like having an EVM. Okay, the Ethereum virtual machine, that's what the software that these nodes will be running. So this EVM will store them. Okay, they will store them for you. Okay, and the reference of this transaction would be in the block. Okay, so this block will contain a list of transactions, a group of transactions. Okay, that's what this block would contain, a group of transactions. Okay, and not only that, okay, I mean the majority part of the block would be the group of transactions, but along with it, it will also have some more information, that is block header. Okay, it will have a block header. So what is a block header? So of course, like if you are interesting, if you're trusting blockchain to handle all of your data, and we know this blockchain is made up of series of blocks connected with each other. You need some way of identifying them, right? You need some way of some way of basically identifying them so that you can get your data back. Like let's say I want to come back and see like what is my NFT price, or what are all the NFTs that I own. I need to be able to retrieve those information. It should not be like I just mint some data on the blockchain, it's lost forever. There should be some way of referring to them, right? So that's the reason we have block headers. So these block headers will contain metadata of the block. Let me write it clearly. Metadata of the block. Okay, so basically we call this as block header. Okay, so block header will have many details like version number, the block hash, the target hash, and also like the previous block hash, so that when these blocks are connected like this, this block will have the previous block hash, so that we can actually refer the connection. Similarly, this block will have the previous hash of the previous hash of the other block, so that we can reference a connection here. So all these will make up a block header, okay, the metadata of the block. So through these header information, we'll be able to identify or locate a block, and then we'll be able to retrieve all these transactions. Okay, but what if I just want to retrieve my transaction? I don't want any other transaction, right? So if you refer it via a block hash, then you'll be getting all the list of transaction. But what if I want one of the transaction here, not everything? In that case, you can use something called transaction hash. If you are working with a dApp or something, you should be actually knowing this. So whenever you interact with a contract, right, you will get a transaction hash, which you will use, in Etherscan or Polygon scan or BSC scan, anywhere to, get the information, right? Get all the information associated with that transaction. That's what will be here. Okay, we'll have a transaction hash, which actually refers as a proof or an identity for the data that you're storing on EVM. Okay, so whatever the data you store on EVM, you can actually get it via the transaction hash. Okay, I mean, it's not like directly you can get it, but there are some ways which actually you can use transaction hash to actually retrieve it. Okay, that's one of the thing about the block. So again, coming to a quick recap, blockchain is nothing but a series of computer or network of computers interconnected with each other in a peer network manner. Okay, and these computers are called as node, and then this node would contain a list of blocks. Okay, a group of blocks. Basically, they keep mining them. Okay, we'll look into mining later, but they keep mining these blocks. Okay, whenever there is a transaction, or there will be time interval. In Bitcoin, it is 10 minutes per block. In Ethereum, it's around 6 seconds or something. No, 10 seconds or something. So you have to keep I think 15 seconds. Yeah, somewhere around 10 to 15 seconds. So you have to keep mining new blocks again and again. So so that the blockchain won't get overloaded with the transaction data. So that's what this blocks does. Okay, this node actually contains the blocks, and these blocks contain the list of transaction. And it depends on the chain. Some blockchain, in very exceptional case, they make the rule like they will generate one block for one transaction. So what we learned here is this block will contain a list of transaction, right, a group of transaction bundled together. But in some blockchain, in exceptional blockchain, it would be like one transaction per block. So for every transaction, you'll be generating a new block. In some other in most of in other case, in most of the blockchain, it will be like a group of transaction will generate one block, and the number of these and this quantity here, the group ranges from other one blockchain to another, but almost everybody does this batch thing. So everybody bundle a list of transaction, and then they make a block out of it. Okay, so again, the block will contain two things. One is the block core, the block body, which will have a list of transactions, and then the header. Okay, coming to the next thing, how is this block generated, right? How is this block generated? So it is generated via a process called mining. mining. Mine. Again, ignore my handwriting here. I'm using my bare mouse here, so I think I'm not able to write them properly. Let me see. mining. Okay, mining basically. Okay, it's mining. So what is this mining? Okay, mining is the process of, it's like a repetitive process. Okay, it's like a repetitive process where you compete and then try to generate a block, like basically propose a new block. Okay, and to propose a new block, you have to basically go through a consensus mechanism. Basically, when I say consensus, if you look up to the word, like the meaning of the word consensus, you'll find it's like agreeing upon in a group. Basically you put up a decision and you have to, and people in a particular community or in a group, they have to agree upon that decision. If you get a majority of yes, then that will be you'll get a yes to that particular decision. And if majority is no, then the decision is actually dropped. Same thing happens here. So when a block is mined, a consensus mechanism should prove that block is valid and it is approved. Only then it will be added to the node here. Okay, or else it won't be, it will be dropped. Okay, so what is this consensus mechanism that is involved in mining? So you should have heard about these two words, that is called proof of work, and then another popular consensus mechanism is proof of stake. Proof of work and proof of stake, there are a lot of other consensus mechanism. For example, in Solana we follow proof of history, and in other in other blockchain there are some more other way of determining their own consensus way. Many Cardano has their own method of consensus mechanism, and Polkadot has their own consensus mechanism. So similarly, like basically all these blockchains will have their own consensus mechanism. So coming to proof of work. So proof of work here would actually require you to put in your effort, okay, via spending your computational resources and solving a puzzle, basically a problem. So what exactly is that problem? So that's one of the thing, right? So whenever we hear proof of work, we often get an answer like, okay, you have to put in your effort. Fine, what is that effort? Your computation power. Okay, cool, computation power is fine, but what exactly are we trying to solve over there? That's the question, right? So you'll actually be trying to find a value that is lesser than a target. So whenever there is the mining required, so the miner has to pick up a data set, right? The miner has to pick up a data set, and then they have to keep on hashing it. Okay, they will get a target value. So this target value would be determined by this block header. Okay, the target value will be here, and the miner has to determine they basically have to come up with a hash which is lesser than this target value. Okay, that's the problem. So let's say this target value is around 2500. Okay, if this target value is around 2500, in worst case the miner has to come up with 2500 hashes, okay, just to prove that this particular their work is actually valid, or to determine a lesser number than this target. In best case, let's say that miner actually find the correct appropriate number that is lesser than target value in the first attempt. That's great. But in worst case, they have to come up with all these number of hashes. So this is why it takes a lot of time for for the miner, and a lot of computational resources. And this will be in a competitive way. There will be many miners will be participating in that, and then it's like a race. So people all these miners to find first before the other miners, so or else they will lose the opportunity to propose a block. And one who finds the appropriate appropriate number that is lesser than the target, they can propose a block. Okay, they can propose a block, and when you propose a block, there will be an acknowledgement. Okay, acknowledgement generated, and that acknowledgement will be verified by the validators. There will be a validator node as well. Similarly, this node which has a block, right? So there will be like here you have these nodes, right? So they will also be having validator nodes. So there are also computers. Okay, there are also computers, there are nothing else. They will be running same Ethereum software itself, but these guys, these nodes will act as validators. So they'll validate these acknowledgement. Where is that? This one. So when the miner actually sends out the when they say, hey, I found the number, I found the result, here's my acknowledgement. So these validators will actually validate them. So if it is valid, then yeah, it is this block is added, or else it is dropped. Okay, if it is valid, then this particular miner will get a reward, and all the other miners who participated to find this hash will also get a complimentary reward. Okay, their effort won't be wasted. And if this is failed, there won't be any reward. Okay, it's failed because it might be, but there might be some invalid processing, or mistake in the transaction list, so it will be failed. So that's what proof of work, how proof of work works. So in proof of work, you have to spend a lot of computation power. It's a very competitive environment, so the miners has to do it very quickly to gain access or to get the opportunity to propose a block. And if it is proposed, they get a reward, or else it is failed. And even though if you're not able to actually propose a block, but if you have participated in this particular competition, you will also get a complimentary reward. Okay, I think when you propose a block, you should get around 1.5 ETH, and as a complimentary, you'll be getting around 0.75 ETH, I guess. That's what I read in some article, but I'm not really sure what is the exact rate, but it should be approximately, it should be around the same thing. Okay, coming to proof of stake. So proof of stake, if you guys haven't heard this before, I'm definitely sure you have heard about this recently, since when Ethereum actually migrated from POW to POS. You should have heard it at least then, right? If you're a die-hard fan of Web3 and blockchain, right? So this proof of stake is like what do you say, a pretty good version of proof of work, where it actually eliminates all this hard work. So proof of stake said no to the power usage, proof of stake said no to the competition, proof of stake said no to this rat race, like all the people participating in this and everything. So instead, proof of stake depended on trust. Okay, it said, if I trust you, you'll get the opportunity to propose a block. That's what it said. And how does it trust someone? By staking. So you have to stake ETH. So what is stake? So stake, as the name said, your money is on stake over there. So whatever you do, it depends on it. Okay, so if you make a mistake, you'll lose your money. Okay, it's something like that. So basically you learn rewards for your amount will be locked for a particular period of time, and you'll keep on earning rewards on top of it. Okay, some percentage of rewards. So now if I decide to mine for Ethereum, right, in proof of stake consensus mechanism, I have to come here, I have to stake my ETH, I have to buy some ETH and I have to stake it. And then depending on my reputation, depending on the amount of stake, and depending on duration of my serving period, okay, like from since when I'm actually I'm mining it. So I'll be chosen, okay, I'll be chosen to mine. Okay, and if my proposal is actually right, if my proposal is right, then I will get a reward, okay, for my work. And let's say I made a mistake, or I tried to do some malice, I try to mess with the chain, then my proposal will be rejected. Okay, it will be rejected, and my reputation will go down. Okay, and some of the ETH in my stake will be deducted. Okay, and I'll tell you where this particular deduction will go. They will add a penalty to my staking to me, and which will be deducted from my staked ETH here, and that penalty actually goes to the validators. So the validator who actually found out that I was messing with the whole consensus mechanism. So Ethereum will deduct ETH from my staking here, and as a penalty, and then they'll give it to the validators. So after that, my reputation goes down, the amount I staked goes down, and duration, of course, it won't go down, but yeah, since the reputation goes down, amount goes down, so it will affect whenever if Ethereum wants to choose me for mining. So this will affect my probability of me getting the chance to mine the next block. So that's how proof of stake works. Okay, proof of stake completely depends on the trust of the miner, and what is the amount they have put up. So that the larger the amount you put up, it means that you are really serious about this, right? So it's like staking your ETH to to get the rights to mine. It's something like that. Okay, so that's about proof of work and proof of stake. So I hope you guys this made clear some points clear for you guys. Do you guys have any doubts until now? So we'll have around 2 minutes for Q&A up till now, and then we'll proceed regarding the Ethereum ecosystem, the layer 2 ecosystem and everything. Okay, do you guys have any doubt up till now? Let me open up the chat. Any doubts, guys? No doubts. All right, cool. That's great. Let's continue. All right, coming to the amazing Ethereum. The Ethereum. So coming to the Ethereum, Ethereum was also is a community-run blockchain. Okay, it's not like one person is like controlling or one organization is controlling. It is managed by the community. All right. So Ethereum is actually a chain built like on perspective of developers. So to enable a lot of applications to run on the like on the ecosystem as well. It's not like completely dedicated to traders where you can only trade coins or where you can only transact via coins or something. So it also allows you to build application on top of it and enable applications running on top of it as well. Okay, that's the reason many people choose Ethereum for any dApps or something like that. And right now we can see many chains are coming out, like Solana coming out. Cardano is also supporting their own type of contracts right now, and Bitcoin also came up with their own contract version, like a language called script. But Ethereum is the first blockchain which actually enabled these things to happen. Okay, that's what I know. But if I'm wrong, please correct me through comments. Okay. All right. So Ethereum, as I told you, is a community-run blockchain, and it offers. Ethereum tried to solve three things, but of course, one thing is not solvable. Ethereum tried to solve security. Ethereum tried to solve, there's one more thing. Okay, yeah, Ethereum tried to solve scalability, but scalability was not actually solve. Ethereum was not able to solve the scalability problem, so it introduced something called layer 2. Okay, layer 2. So Ethereum handles the security, Ethereum handles the validation. Okay, Ethereum handles security. Oh, I'm just scribbling here, just give me a second. Right. Security. Okay, and Ethereum handles the validation. Okay, Ethereum handles security and validation. And here comes layer 2. So if you know Polygon, if you know BSC and everything, Binance Smart Chain, I'm not talking about the Binance, there are like multiple version of Binance. So I'm talking about Binance Smart Chain. Okay, so those chains are layer 2. So what is layer 2? So layer 2 is like a extended version of Ethereum. Okay, so what these layer 2 will do is they handle scalability, which was not actually possible by Ethereum to do, provide. So this layer 2 will handle scalability. Yeah. Okay, so what these actually layer 2 do? So what this layer 2 will do is they provide all the infrastructure necessary for scalability. Okay, to scaling your dApps. And then what these how this layer 2 will handle the transaction is, and they also reduce gas fee, which Ethereum was not able to do it. Not sure whether after the merge to POS the gas fee has reduced or not, because I personally haven't tried on transacting on mainnet on Ethereum, because I'm not so rich to pay Ethereum gas fee, which is like Ethereum price around 1 lakh right now, right? So let's say the gas fee is around 0.05 or something, so that would be a big amount as well. So I've heard that there is not much fees, the gas fee reduction found on Ethereum even after the merge. There's a slight improvement on the transaction speed, but not much on the gas. I'm not sure about it. Confirm that to me if you guys know about it on the comments. Okay, so but layer 2 handles this. Layer 2 handles this gas fee reduction as well. So what happens is layer 2 will bundle the transactions, right? So let's say for some interval of time, people will keep on transacting with layer 2, and this layer 2 for every interval of time they bundle all those transactions and put it on Ethereum for validation. Okay, and layer 2 has to pay gas fee for that, right? Layer 2 has to definitely pay gas fee when they put up all these bundled transaction on the chain. So layer 2 will divide those transactions. Let's say layer 2 will bundle 10 transactions and then put it on Ethereum. So for all these 10 transactions, layer 2 has to pay around 0.1 ETH as gas fee, 0.1. So layer 2, what will do is it will divide that 0.1 to all these 10 transactions. Okay, so it will put up all these 10%, 10%, 10% of gas fee for all these transaction. So when I'm transacting with layer 2, I'll pay 10% of that 0.1 ETH, and similarly though all those other 9 people will pay 10% of that ETH. So now layer 2 has 0.1 ETH to pay gas. So now layer 2 will use that ETH to pay gas whenever there is transacting. Of course, I'll be paying in the cryptocurrency of that particular chain, but that will be converted. Okay, and that's how layer 2 will handle reduced gas fee. So it's not like I'm paying 0.1 ETH myself, 0.1 ETH equivalent of gas myself. I'm just paying 10% of it, and other 9 people are paying the same thing. So layer 2 will bundle all these 10 transactions, and then they will put it on Ethereum. Okay, layer 1. So Ethereum is a layer 1 chain. Layer 1. So layer 1 is the foundation of, it's like a founding chain. Okay, foundation layer of the chain. Okay, so this is all about layer 2 and Ethereum. Okay, so moving on. All right, so moving on, we have one more thing, one last thing, that is smart contract. Okay, we have one thing that is called smart contract. So what exactly is this thing called smart contract? So Ethereum introduced this thing, so this term called smart contract, so that to enable people to build dApps on top of it. So what exactly is this smart contract? So smart contract is, well, as the name suggests, it's a contract but which is smart. Yeah, of course, that's what the name suggests, right? So smart contract essentially is a code. Okay, it's like a code. Okay, it does something. Okay, only when the conditions are met. Okay, let's say we have few lines of code here, and someone is trying to send a request to this one, and this particular contract will check whether the data inside this request actually matches the condition. And let's say we have around 3 conditions here, right? 3 conditions here. So this smart contract will check which of among these 3, which is the condition that matches with this particular data. If any of this function matches, then of course it will execute that particular task or that particular instruction. If none of these instructions match, it will be rejected. Okay, a good example is, let's say we have a contract, okay, that transfers some amount here. Okay, let's say we have a withdraw function here. Okay, let's say we are withdrawing some whatever the contract is holding, whatever the balance this contract is holding, we're withdrawing it. And this withdrawing can only happen by the owner. Only owner can withdraw this particular balance. So now let's say owner is here. This is the owner, and this is Pawan. This is me. I'm not the owner here. Okay, and then there is the hacker. Okay, here's the hacker. So let's say first Pawan sends the request to withdraw. Okay, it will be denied because I'm not the owner here. Okay, and hacker try to send the same request again. It will be denied. Okay, because hacker cannot do that. But owner sends the request, it will be accepted. Why? Because owner this contract knows who's the owner, because the contract will store the data of the owner. It will match with the caller address, and if it is valid, then it will withdraw. It will send all the balance to the owner address. So Pawan and hacker cannot actually access it. That's what makes it secure. And what is that all? Is that all about smart contract? No. The one thing is, once you deploy a contract, you cannot change it. So it means that, let's say I have a community of people. I show them like, hey, we came up with this new application thing, and here's the contract. And this is the, almost every community does that. Every Web3 community actually open source their contract so that people can actually see and verify that it's trustworthy. Okay, so contracts are already also is always public. It's always visible to public people. So I display this to my community saying that, hey, this is my contract, so this is how the transaction happens. So when you are interacting with it, this is the flow. This is how the flow actually happens. And now my community will say, hey, good job, man, you're doing great. We'll actually support you. We'll put up money on your application. So that's great. Now we earn the trust of the community, and then we deploy the contract. Now what happens is, if this let's say blockchain allowed us to update the contract. Okay, there was nothing called immutability. Let's say this contract was mutable. Then what could happen is, I can actually show the correct contract to my community, and then deploy it, and then go back and change it however I want. Okay, so that would be a disaster, right? Let's say we have a withdraw function here that's only set to owner, and I could actually add one more address that's set to my, right, Pavan, and so when I request, it won't be denied. I can actually drain all the funds. That's possible, right? So to avoid that, blockchain made this immutable. So once you update or deploy your contract, you cannot change it. So whatever the contract I show to my community, that's what I'll be deploying, and that's what will be visible to the community. Okay, that's what will be interacting, that's what we'll be using actually. So this makes it even more like trustworthy, right? So first thing is like we'll open source the contract so people can go through it. People can actually see every line of code, seeing that what's happening here, what's happening there, who is actually withdrawing, who is eligible to put up money, who is eligible to take the money from there, and what is the owner's authority here. Does the owner has any backdoor where they can actually come and get all the funds? Like they will see all of those things, right? So that's what smart contract does. Okay, first thing is people can verify it, and once you deploy, it's like you can say with confidence that whatever you saw, that's what you'll actually be getting on the blockchain. The blockchain won't allow us to change anything. Okay. Alright guys, so this is why the smart contract is very trustworthy, and this is why people put their money on it. Although we know that we keep reading many news where people lost millions of dollars on smart contract because all the dollars is locked inside smart contract. This is not the issue of the smart contract. This is actually the issue of the code who actually, the people who actually wrote this code. Because if there was no way to withdraw the funds, then how would you expect a blockchain to give you funds, right? So that's not the issue with the contract. So this is what the whole foundation of the smart contract is. Okay, cool. So that's it guys. So this is what I had in mind for today, like just to cover the basics of everything. So once we write the smart contract, we'll be writing a crowdfunding smart contract where like this is how it will be. Like we'll have a contract here. Okay, so people can come in, they can register their project. Okay, they can register their project. This can be anyone, this can be users, and then other users can come in, they can get a list of projects. Okay, they'll get a list of projects, this contract will send it, and then they can choose to fund any project. Okay, they can choose to fund, and the project owner who actually updated, they can interact with the contract to withdraw those funds. Okay, let's say I have a project and then I need 1 million of funding. So I put up the list here on the contract, and users get a list of all these funding. They can go through the details and everything, and if they like the if they like the project, they can actually fund it with their tokens, and we'll be using ERC20 tokens for that. Okay, and then they can get back their funding. Okay, so the project owner can withdraw the funding. Okay, if they wish to like hey like I want like it's let's say out of 1 million I reached around what do you say 0.5 million, I reached 0.5 million. So now I need money actually to, let's say I'm hiring, or I'm going to release my MVP, so I need to my MVP is doing good, now I have to pay for marketing or something like that. So I have to withdraw this 0.5 million, whatever is available, so I can withdraw it. Okay, so this is what we'll be doing. So we'll be also building a React application as well on top of it, so that people can get an interface where they can actually see the list of projects. People can come and upload their projects, people can see how many what is the amount of funding they have received, and they can get a withdraw button if they're owner, where they can click withdraw, and then they can withdraw the entire thing. Okay, along with this contract, we'll be adding many things access control, so that only people who are authorized can call certain methods. It's not like anybody can call this withdraw function, right? It should be secure, so we'll be limiting that. Okay, so similarly we'll also be looking into so many things like transferring token. So when user fund to a project, we have to transfer the tokens from their account to the contract's account, right? So we'll also be looking into that as well. Okay, so I really hope this actually gets you exciting, because this contract would be really exciting. You'll learn a lot of these things. You'll learn modifiers, access controllers, state mutability modifiers. You learn about struct data type. You learn about token transfers. You learn about including ERC20 interfaces. You learn about ownable contracts, and probably pausable contract as well if you guys want. And yeah, you guys will be looking into so many things here. Okay, So, all right, guys. So if you guys have any questions, you can put up on the chat here, or you can also drop a comment, and you can also join our Discord community as well. Like if you have any questions, let's say if you guys want answers, it might be for crowdfunding project with this current project, or it might be your own projects, either in the full stack or in the web development or in the blockchain space. You can drop a message to us on our Discord. All the links are available in the chat. Sorry, in the description. And we're also having few of our own workshops running. One is on building a blockchain bridge, like from scratch with React, Solidity, and Morales. So you can take a look at that as well. And also we are having a new workshop coming in that's called Twitter clone, building a Twitter clone with React, GraphQL, and MongoDB Realm, which is a very amazing stack, web development stack. So if you guys are interested, all the links are in the description. Please do check it out. And then I really know, since you guys are here from Ur-Hackathon, I'm really happy to collaborate with these people, and really excited to see all your projects that you guys are building. Okay, so we'll be available on the hackathon day, so come say hi to us on our Discord. Okay, so with that said, thank you so much, guys. So I'll just wait here for like 2 to 3 minutes. So if you guys have any questions, you can drop it on the chat. Okay. Think I came back. Think we missed it. Cool, no problem. I have it, have the chart in my other screen though. You can actually text me. Any questions, guys? Anything that you guys want to ask, or if you guys want to talk about any other, any doubts in apart from this session, if you guys have any doubts on the Web3 space or blockchain space, you can talk to me. No questions? All right, then no problem. Cool, guys. So tomorrow is Sunday, right? So tomorrow we won't be having any session. So see you guys on Monday. On Monday we'll start our contract. Okay, so we'll start writing our smart contract for crowdfunding platform. I think we might take around 2 days to complete it, and then